Guys, it's your soft-spoken scientist. Today you'll learn the fastest way to tell if a reaction is spontaneous, and then we'll level up and calculate delta G from delta H and delta S with 8 practice problems and full work. So let's get started. So we're dealing with delta H here, which is enthalpy. Enthalpy is your heat energy change, okay, the change in energy. And the change in heat energy specifically is what I should say. And you have delta, this triangle just means the difference in. And you have delta H is less than 0, which is, again, delta H is basically the reaction's heat energy change at constant pressure. Delta H is less than 0. So when you see that, you'll know it's exothermic, exiting, right? So you're going to be releasing heat, often helps spontaneity. You'll have delta H, which is greater than 0, which is endothermic, which is going to absorb heat, often hurts spontaneity, right? And then this is how I explain it in plain English. Delta H is negative, the reaction gives off energy, usually helps reactions happen. Delta H is positive, reaction needs energy input and it's harder to happen. Okay? That's like the best way you could really go at this thing. Now, let's talk about entropy. Delta S measures how spread out or disordered energy and matter are. So if delta S is greater than 0, you have more disorder, you're more spread out, you're more chaotic. If delta S is less than 0, you are less disordered, you are more organized. So, like, if I have a dirty room, right, that's definitely going to be more disorder, more spread out. Delta S would be greater than 0. I want you to say this exactly. When you create more gas particles, disorder increases. Delta S is positive. When you create fewer gas particles, disorder decreases. Delta S is negative. When gas turns into liquid or solid, look, if I have a gas, right? Like, let's say, unfortunately, someone cuts the cheese, okay? If someone cuts the cheese, it smells awful everywhere, right? But if I just have, like, it in the gas in a liquid form, and it's all, like, in one bottle of Evian, right? Guess what? The disorder went down. It's all confined. Or if it's, like, a solid... or if the fart, I don't know how to, a gas is like a solid chocolate bar, a solid ball, right? It's all confined still. So it's not as messy. The disorder decreases. Delta S is negative, all right? I felt like hopefully those were some easy examples for y'all to do. And then kind of reverting back to delta H real quick. Delta H being greater than 0, I told you guys was endothermic and absorbs heat. Like you're indoors, you're absorbing the heat. Okay, I thought that would maybe help. Okay. Now, the next thing I want to talk to you guys about, which you just have to like practice and memorize and kind of drill it in your heads and you should be fine, is Gibbs Free Energy, aka delta G. This is the variable that tells us if something is spontaneous or not. Spontaneous means you're able to occur on your own. And then you have non-spontaneous, which basically is means it's not thermodynamically favorable under those conditions. You'd have to continuously drive it, okay? So if we look at this rule, you'll see that we have delta G is less than 0, so that would be spontaneous. So delta G being greater than 0 is non-spontaneous. Delta G equals 0 is equilibrium, meaning everything's balanced. There's a formula you must know, which is that delta G equals delta H minus T times delta S. That formula is how we calculate delta G when they give us the other things. Now, here's another thing you need to know. T in that formula right here has to be in Kelvin. You need to know that and the only way to get to Kelvin is by taking the degrees Celsius plus 273 and going from there. And then I want you guys to know what delta S and delta H are. So if you look back, you'll know that delta S is for your entropy, and delta H was for your what? Enthalpy, your heat energy change. Again, delta H is usually in kilojoules, delta S is in joules. So the way I always thought about it was like HIJK, like it's all kind of like in the alphabet. It's kind of how I knew it. And then I knew delta S would be with joules because it's like the last remaining thing. And then you also need to know 1 kilojoule equals 1,000 joules. That's a lot of rules I just gave you guys, but I think you guys will be fine, okay? So we're gonna jump right in. Now that we understand the rules, let's jump into practice problems. A reaction has delta G equals negative 18 kilojoules per mole. Is the reaction spontaneous? So we know that delta G is definitely less than 0 because it's negative 8. Is it negative 18 less than 0? Yes, it is. Absolutely is. So it looks like the answer is yes, it is spontaneous. And that's great. And I'm in my unit. I'm in kilojoules per mole, which is what I like to see with delta G, depending on the context. That's good. Here's another easy one, hopefully. A reaction has delta G that is 7.5 kilojoules per mole. Is it spontaneous? Well, I know delta G is positive, which would be, what do you think? What do you think? Yeah, non-spontaneous. Good job. So it's non-spontaneous. Okay, let's try and it'll only get harder. Okay, practice problem 3. A reaction has delta G equals 0. What does that mean? Come on now, I just told y'all. It's at equilibrium. And you know, remember what equilibrium means, right? Equilibrium. I cannot spell. Equilibrium, right? But here's the thing. Equilibrium, it means the forward and reverse reactions are happening at equal rates. Let's look at practice problem number 4. Okay, delta H equals negative 50 kilojoules per mole. Delta S is negative 100 joules for moles of Kelvin. Divide by moles of Kelvin. Temperature is 298 Kelvin. Find delta G and spontaneity. All right, now we calculate delta G. Delta G equals delta H minus T delta S. So the first step is to convert delta S into joules, into kilojoules, I should say. And the way to do that, because I want all of this in kilojoules, but you're usually going to get them, again, delta S is usually in joules, delta H would be usually in kilojoules. I meant given to you. So you're going to take the delta S and convert it into kilojoules. So let's do it. Negative 100 joules for moles of Kelvin. And I'm going to divide by 1,000. And when I do that, I'm going to get negative 0.100 kilojoules for moles of Kelvin. And you may be saying, well, how did you know that? Well, I know the formula is that it's 1,000 joules for every 1 kilojoule. So if you have negative 100 joules for moles of K, you would put 1,000 joules in the denominator, 1 kilojoule at top. Check that out. Bam, I canceled my units. So then I just say, okay, that's negative 0.100 kilojoules for moles of Kelvin. Depending on your teacher, you may be able to write it sloppy like that, but maybe they want to see your work. It just depends. Okay. The next thing is now we plug in. So we have delta G equals negative 50. And they're both in kilojoules now. So that makes me happy. So I have negative 50 times negative 298 Kelvin times negative 0.100. And again, some teachers want you to write the work out, some don't. I'll just write it out for the heck of it. And when I do that, you're going to see that we're going to calculate that and get delta G is negative 20.2 kilojoules per mole. Okay? Delta G is negative, so the reaction is spontaneous. There you go. Next one. A lot of teachers don't want you to write out the units just because it doesn't entirely always cancel out. It's just part of it. So here we have a problem. Delta H is 40 kilojoules per mole. Delta S is 90 joules for the moles of Kelvin. T is 298 Kelvin. Find delta G and determine spontaneity, right? So here's the deal. Again, we're going to convert delta S into kilojoules. So we're going to say 90 joules. And then we're going to say there's 1,000 joules for every 1 kilojoule. And then you're going to end up getting 0.090 kilojoules for moles of Kelvin. And then now we're going to plug this into the formula. We're going to say delta G equals 40. Because remember, delta G equals delta H minus TOS, as I like to say it. I treat the triangle like an A. Equals 40 minus 298 times 0.090. I'm going to put the units in there. You can see Kelvin cancels out. And then you're going to have negative 40 kilojoules per mole. Okay. Now, when I plugged all of this into my calculator, right, I got delta G equals 40 minus 26.82, and I got 13.18 kilojoules per mole. This is a positive number, so it's non-spontaneous. Okay?